Okay, students, let's continue module 1.6. So what we figured out yesterday is the hare and the tortoise, they wanted to do the race, and then the hare, this is what he was, this is what his distance coverage. So the formula was D equals T squared. So the distance with respect to time was changing as T squared, and then for the tortoise it was going with 2 to the T. Now what we also figured out yesterday is that the tortoise, he had a head start of 1 meter. So the hare started once the tortoise reached 1 meter, then the hare started running. So at 0 time, when hare was at 0 distance, that time the tortoise was at distance 1 meter. So then we made this chart, we made this table yesterday and figured out that between 0 to 6 seconds, there were 2 times where they both were at the same distance. Okay. So now let's find out what's happening here. What is it asking us to do? So it is saying that if the race course were 15 meters long, who would win, the tortoise or the hare? So if it is 15 meters long, then to win it, we need to find out who is reaching 15 meters first. So instead of figuring it out all over again, what we can do is, if we come here, then look how here it is telling you that when it's t equals 3, the hare was at 9 meters and then the tortoise was at 8 meters. But then when it was t equals 4, they both were at 16 meters. So between the third second and the fourth second, somewhere between, they both reached 15 meters. So if we make a chart between 3 seconds and 4 seconds and find out their distance, then we can easily figure out who reached 15 meters first. So let's do that. So we will be making a table and for both of them. Okay, so here we are. This is your T. We will be going from third second to fourth second, but let's go by 3.1 second, 3.2 second, and on. Okay, so what we already know so far is that their distance formulas are, this is for the hare and 2 to the T is for tortoise. And what we know is they both were, one of them here was at 9 meters and tortoise was at 8 meters when they started at 3 seconds. At the fourth second, they both were at 16 seconds. So we need to find out what happened in between these 2 seconds. Whoever reached the 15 meters first, that person would win. So all I will do is I will plug in my calculator. I'll do 3.1 and because that is my t, and I will square it. Okay, so if I do that, I'll be getting 9.61. If I do 3.2 and I square it, so then I will be getting 10.24. Okay, and I will continue. Same way, I'll be doing 2 to the t power. My t is 3.1. So if I do that using my calculator, that 2 has 3.1 power, I'll be getting 8.57. When I do 2 to the 3.2 power, I will be getting 9.18. So now what I want you to do is pause the video and find out what are the values here. Okay, when use a calculator, and when you are done, then come back and check with mine. Okay, so do that please. Okay, so what I figured out is when I filled this whole table, then what I figured out is that the here, when it was 3.8 seconds, he was at 14.44 meters and torus was 13.92 meters. But then when it was 3.9 seconds, then here reached to 15 meters first, while the tortoise was still a little bit behind. So he was at 14.92 meters. So because the hare when reached the 15 meters mark first, so the hare will win. Okay, so that's that. Now let's find out what's happening in the next one. So this one is so it is asking us to use the distance formulas or distance equations that we have for tortoise. So this is for tortoise and this is for hare, and explain the speeds of the tortoise and the hare in the following time intervals. So these are the time intervals. Now think about it, the speed it is asking us to calculate, and speed is always the distance over time. Okay, in our case these are the distance formulas. So what we will do is this is how we will calculate that. So we will find out speed between these two times. We will say d2 minus d1 over t2 minus t1. This is your t1, this is your t2. So this is t1, t2. Now when t is 2, we will calculate what is for tortoise, what is the distance at that time by plugging this 2 here. okay? And then what is the distance when t is 0, and that will go here. So let's do that. So we will use this formula, plug in t. T is 2, t2 is 2, t1 is 0 over then t2 minus t1, t2 is 2, t1 is 0, and when you calculate that, it will be 1.5. Okay. Now let's do next one. So we will do t to the fourth power, then 2 to the second power, then 4 take away 2. That will give you 2 to the fourth power is 16. 2 to the second power is 4. You divide it by 2. That is 12 over 2, which is 6. Okay. Let's do next one. So it's 2 to the 6, take away 2 to the fourth over 6 take away 4, which is 64 take away 16 over 2, which is 24. Okay. Now it is asking us to use infinity, so 2 to the infinity power take away 2 to the sixth power, so infinity take away 6. Now because we do not know exactly what value we are looking at, so instead of using infinity, you can use t, because we do not know what exact value we are looking for. So instead of using infinity, we use t, and that gives us a speed formula pretty much for the tortoise. So let's do the same thing for here. So this one we will be plugging in for t, we will be plugging in, once we'll plug in 2 and then we'll plug in 0. So we will get 2 to the second, take away 0 to the second, over 2 take away 0. 0 to the any power is always 0. So this will be 4 take away 0 over 2, which will give you 2. Okay. Then we will do 4 and 2. So 4 to the second power, take away 2 to the second power over 4 take away 2. That will be 16 take away 4 over 2, which is 6. So if you look at it, their speeds are same between the interval 2 and 4. Okay, this is a crazy observation here. Then let's do next one. We will have 6 is your t2, so 6 squared take away 4 squared over 6 take away 4, that is 36 take away 16 over 2, which is 10. Okay. And then again it is asking us to use infinity. Infinity squared take away 6 squared over infinity take away 6. Now since we do not know what exact value we are looking for, so instead of using infinity we will use t. So t take away 6. So this is pretty much gives us the speed formula for the hair.